Yeah, dear participants, welcome to lecture 13 of micro irrigation engineering subject. Lecture 13 is on soil and plant water monitoring instruments. We learnt about soil water, we learnt about plant water and how they are interrelated. When we are interested or we want to give irrigation to the crop, we need to know how much amount of water available in the soil, how much water it has been transported from the soil root system, plant root system from the soil to the plants. So, we need to install or in the laboratory we should bring sample and then analyze soil parameters, analyze plant parameters, accordingly irrigation can be given to the plants. So, in this particular lecture we will be covering different soil moisture measuring techniques as well as soil water monitoring instruments. We will also learn what is plant water potential and then what are the instruments that can be used to monitor plant water potential. So, when we talk of soil and plant water monitoring applications, which are the areas where such monitoring is important. So, it is for agriculture, it is for hydrology, it is for meteorology. When we talk of soil water, means all three areas need soil water information, soil water data. When we are talking about plant water monitoring, it is relevant for agricultural water management, it is relevant to the area of hydrology, hydrologic modeling or several hydrologic parameters evaluation. You need plant water monitoring also. Now, in case of when means your agriculture, we talk of irrigation scheduling and it is a control. So, soil and plant water monitoring applications, it is applicable to irrigation scheduling and control, which has relevance to agriculture. It has relevance or application in ecosystem and crop water balance. It is when we are interested to know what is the efficiency of irrigation system. So, there also soil and plant water monitoring is important. For hydrological monitoring or hydropedology catastrophic event monitoring, the soil and plant water related parameters are important. So, when we talk of soil water is applicable to agriculture, hydrology, meteorology, whereas when we talk of plant water monitoring parameters, those parameters are applicable to agriculture and hydrology. Now, when we are talking about soil water measuring techniques, so one of the very simple method is gravimetric moisture content, or another way that we want to express in terms of volumetric water content. So, how much a soil consists of solid particles, the soil solid particles, it consists of pore space. These pore spaces could be partly filled with the air, it could be partly filled with the water, or it can be solid. So, when we are interested a total soil volume, so some certain percentage of this from the volumetric point of view, it will have air, it will have water, or when it is saturated all the pores are fully filled. And then when we talk of soil water with reference to irrigation, so when the gravitational water is removed, so water available in the pores and then partly filled with the air. So, if we say 15% of the volume is air, 35% of the volume it is water, or 50% of the water, means it is in the volumetric unit, means we are telling that how much is the percentage of water content is available in a given soil column. Gravimetric matter means when we are expressing in terms of weight, means amount of water available per unit dry weight of the soil. So, gravimetric method or technique, it is a direct measurement method which can be used to determine water volumetric basis or gravimetric method. So, there are different methods to monitor. So, gravimetric technique, tensiometric technique, then nuclear technique where radioactive materials are used, and then electromagnetic simple principles, these are applied to find out the soil water content. Then remote sensing is the another way of, without coming in contact with the soil particles, without coming in contact with the exactly object, we are monitoring the soil water status. So, gravimetric method, as it says that, and it is a oven drying method, means bringing sample from the field and then we find out what is the percentage of the dry soil versus percentage versus the weight of the soil. So, we can express in terms of the moisture content by percent, that weight of water divided by weight of the soil. So, this way one can find out the what is the moisture content in the soil sample. So, there are advantages, it is a direct measurement, it ensures accurate measurement, calibration of other soil moisture, means there are several other methods which are available, which I will be talking about, tensiometer method or radioactive material using, that is neutron moisture probe or TDR. All these are calibrated by using the gravimetric way of finding out the soil moisture content. It is not so gravimetric method, it is independent of soil salinity or a particular type of soil, and it is one can easily calculate the value of moisture content. Only thing that it requires 24 hours time. So, soil sample taken 24 hours before that, so it does not give the real time, but there is a delay of 24 hours. Tensiometric technique, that is by using the tenacity, means we are measuring the capillary tension or energy with which water is attached or available in the soil pores. So, it is the capillary forces which are holding the water within the pore. So, this is a means the potential which we are measuring, this potential is metric potential in when we are using tensiometer. So, tensiometer consists of a porous cup connected to a continuous liquid column to a vacuum gauge or transducer. Here in the right side, what we are seeing, that there is a tube, and in this tube is filled with the water, and the top of the tube it is attached with a a stopper, that is a silicon stopper, and then the there is a pressure transducer. So, when we are this means we are piercing in the needle. So, pressure transducer it gives the how much is the soil moisture, suction or tension it is available, and these data can be read by the readout unit. So, it is a simple device, only thing that it has got a limited range of measurement. So, it has got a limited range of measurement, that is 0 to 80 centibar, minus it is written that it is a negative pressure or tension we are measuring. So, it is not a means when the soil is too porous, it is not applicable for the other soil which are too porous. However, it gives a precision reading, and if the soil water tension it exceeds below 80 centibar or it goes below 80 centibar, that is used for monitoring the irrigation or irrigation control, but when it exceeds the value of 80 centibar, then there is a chance that air which is available in the soil pores it may enter. So, that may interrupt the observation. Nuclear techniques means, as the name it says that nuclear techniques means here it is using the radioactive material. It gives a precise estimate. However, this method slowly it has been discarded by the international community because of the use of the radioactive material. So, it is a non-destructive, means samples are not to be brought, and then access to tube is driven in the field, and for the entire crop season observation can be taken at different depths. But it is a non-destructive indirect method and commonly used for repetitive field measurement of biometric content, means for the entire crop season observation can be taken. It is based on the how much is the hydrogen nuclei, means water content it is available in the soil. So, water content in the soil. So, fast neutrons which are emitted by americium and beryllium, which is a source, that are thermalized, slowed down by the hydrogen ion present in the water, present in the soil sample. It measures slowdown of fast neutrons emitted into the soil. So, it consists of 3 components. One component, this on the top what you see, this is the unit, which is a counter unit. So, it has got a counter, and then there is a here this part it is a probe, and in this probe there is a detector. Then what happened when from this source the fast moving these neutrons they are emitted. So, so that is it causes the thermalization of the neutrons, and this thermalization is practically it depends on the amount of water molecules available in the soil. So, here the amount of moisture content and then number of counts which are there from this it is counted, there is a linear relationship. So, that is measured or this is calibrated, and then moisture content is calibrated with the number of fast moving neutrons with slowed down neutrons, and then this is a linear relationship it is obtained. As such, there are some certain advantages of using the neutron scattering method. It is a non-destructive method, possible to obtain profile of water content in the soil. Water can be measured in dry as well as in wet phase. It can be automated for one site to monitor spatial and temporal soil water, means after the observation is taken, one can take to the another tube So, as such whole unit of measurement it can be shifted from one place. So, that is from the spatial point of view, and then the temporal means multi time the data can be collected. Measurement directly related to soil water content. So, it one can directly from the calibration curve one can find out what is the what are the what is the amount of moisture content available. There are some disadvantage or limitation, that it is a costly equipment, it is dependent on the bulk density and salinity. There is a radiation hazard. This is the one of the major limitation of using this equipment, and particularly when we are taking observation from the first 15 centimeter of soil, the fast these the fast emitting neutrons, it may come above the surface. So, this is not recommended to use for shallow depth soil water monitoring. Then another method is nuclear technique, that is also gamma attenuation. This also uses radioactive technique, and changes in the weight density. Here the what is the change in the weight density, it is measured, and moisture content is determined from the density change. It measures the means it is calibrated in terms of biometric water content, and it give a very fast response. It is less than 1 minute observation. There are some advantages. It gives mean water content in depth, and this particular device, it can be connected with the automated irrigation system, and then any changes in the temporal changes in the soil water, it can be measured. It is a non-destructive, means soil samples need not to be brought. It is in the field at the site itself, the observation can be measured. It is restricted to soil thickness, means for the shallower depth, means the thickness of 1 inch or less, but with very high resolution data are obtained. So, if someone wants to have the data of less than 25.4, then one can get the this particular device. It is affected by soil, means density of the soil. When it is changes, then the observations are affected. Then electromagnetic techniques. This technique is based on the several properties of the soil that vary with soil moisture content. The observation can be measured in terms of the resistance, or that is resistivity of the soil, or in terms of the capacitance. That is between the electrodes in the soil is measured for soil moisture content. So, resistance in terms of ohm, or sometime the capacitance based, the observation is measured. So, a device which you are seeing, this is a granulometric soil moisture sensor, and then there are porous blocks, gypsum blocks, which are available, and this gypsum block which you are seeing here, this gypsum block, inside there are 2 electrodes, and these 2 electrodes are connected with a probe, and then on the top there is a readout unit. That readout unit gives the observation in terms of voltage, or in terms of the resistance, and that value is calibrated in terms of the soil moisture content. So, if only there is a limitation that the calibration made, it changes with the time, because of the, if continuously when irrigation is be given, and then if the fertilizer is given, then soil salinity as well as the chemical content in the soil, that as well as in water, that changes the calibration curve. The response time means these such devices are kept in the field for longer period. For the entire crop region it can be kept, and then observation is taken, and those observations are interpreted what is the available moisture content, and these units are also used for finding out the moisture content, and that can be attached with the automated irrigation system. Now, capacitive sensors are available. The effect of soil moisture sensors here, when I am telling about the capacitive sensor, means here it is the observations are the affected by the dielectric constant. So, the major parameter it is brought in terms of volumetric soil water content. Response time from such devices are instantaneous, and this gives relative better response as compared to the resistive unit, and they are means there is a long term stability of such observations are also a question, and then relatively as compared to resistive or granular soil moisture sensor, they are expensive. The another important device are which has been now commonly used, this is a time domain reflectometry. So, in time domain reflectometry, the speed of an electromagnetic signal passing through porous media, it varies with the dielectric constant of material. So, TDR in short form we say of the time domain reflectometry, it measures apparent dielectric constant of the soil surrounding the waveguide line. At microwave frequencies, which is measured in megahertz or gigahertz, the propagation of velocity, it depends on the length of the electrodes, and then the how much is the length it is given, and also the how much time it takes. So, the propagation velocity is given by L by 2 t is the function of soil bulk density, bulk dielectric constant, and this can be given by equation that dielectric bulk the bulk dielectric constant is given by C by V square, which is this V the velocity of propagation through the transmission line of length L, and t is the time when it is transmitted from the source, and then how much time it returns back. So, it is divided by 2 multiplied by L, that gives the dielectric constant. So, this is measured, and then means it is given the t is the travel time for the pulse to transfers the length of the embedded waveguide in both direction, that is a downward as well as backward direction. So, this is the part which we are seeing, that is a 3 rod probe, where the electromagnetic waves are transmitted, and then the observation it comes. So, observations are monitored in terms of, it is calibrated in terms of moisture content, and it is expressed in the volumetric unit. So, so much means water content is expressed, so many means volume out of, so means volume. So, it is given in cc by cc, means that is cubic centimeter by cubic centimeter, sometime it is expressed in percentage also. So, the soil bulk density constant is governed by dielectric constant of liquid water, which is 80, and then the dielectric constant of soil is less, means it could be 0 to 4. So, large disparity in the dielectric constant makes the method relative insensitive to composition of the soil texture. So, volumetric content means major parameter is volumetric water content, and response time is very fast, it is less than 28 seconds, and one can there are certain advantages, only thing that it is a quite expensive equipment, and this system can be automated. Then frequency domain reflectometry, this is another device, it is working in the same principle more or less as TDR, only thing that here the frequency is high frequency, it is transmitted pulses are transmitted. So, FDR measure the soil dielectric by placing the soil in effect between the two electrical plates to form a capacitor, and this explains the term capacitance. So, which is used to describe what these instruments measure. When voltage is applied, the electric plates a frequency can be measured. This frequency varies with the soil dielectric constant. So, that is a another device and a simple device. It gives considerably precise observation as far as that, but this device is also an expensive device which is used for measurement of soil moisture content. So, now, the another way of monitoring soil water content is remote sensing, and in remote sensing we are using active as well as passive sensors, and the active sensors where the from the means radar or means your side looking radar or synthetic aperture radar pulses are being thrown, and then the reverse pulses are measured. So, passive when this means this measures in terms of the emittive property of the material, emission property of the material, where active sensors is measured in terms of the scattering coefficient, and then which is given by sigma 0 decibel. So, that depends on the sigma 0 depends on the dielectric property of the soil, geometric properties of the how the soil means the rays or beams are transmitted from the source, and then other system parameter those are used. So, this is what you see how they from when it is a airborne radar, and then the pulses are transmitted. So, this pulse it goes, and this let us say these are the targets. So, these targets are the when the pulse is transmitted, then it is transmitted back to the system, and then these values are analyzed in terms of the moisture content, and then these are the some of the the sensors which are there, synthetic aperture radar in the space. So, CSAT, LMAZ, that is ERS1, SIR radar SAT. So, these satellites they have got the sensor where the active microwave remote sensing, where P band, L band, S band, C band antennas which are working in different frequency are utilized to monitor the soil water content, but it is limited to certain depth. Plant water monitoring, it is a very useful important thing, because soil is indirect way, means it is we are getting sample, but frankly means speaking that we need to monitor plant water from irrigation point of view, we are irrigating to plant. So, if I know about the plant systems, we will be able to give water to the plants. So, it is useful to determine water deficit, and irrigation needs, there are different crops, and it has got different requirement. So, we need to give water to the different crops which are having different water requirement, and then water means what happened, the water potential in the plant it differs in many ways, and atmosphere, it is the atmosphere which provides energy, and then it because of this energy the plant through the process of evapotranspiration, through the process of transpiration, it extracts moisture from the soil. So, this particular information which when we are talking the amount of transpiration it takes place, that is the plant process, and the amount of water which is withdrawn from the soil, that is a soil water. So, both the system it works when the plant is grown in the soil media. So, basically it involves that water moves from the higher potential, this is the basic fundamental involved, that water moves from the higher soil water potential to the lower soil water potential, or higher plant water potential to the lower plant water potential, and between points of equal potential means there is no movement of water. So, it is at least at it is same, and when we say for the pure water the pressure, the water potential, it is 0. So, water potential value is always negative, because this negative is causing the gradient to flow. So, from higher potential to the lower potential water will move. So, psi w increase in the pressure potential, and it is a decrease by addition of solutes which lowers the solute potential. So, if we put total water potential, so total water potential is given by pressure potential plus the osmotic or solute potential plus the electrical potential and plus gravitational potential. So, these components the psi e, when we say electrical potential, these are very negligible from the, if water is having 0 concentration of the salt or this value is very small. So, it remains same, there is not much change in the value, and G is also, when the plant is of a smaller height, this does not play a role. So, these two components can be taken as a very negligible, and then the total soil water potential can be given by psi p plus psi s. Now, this the plant water potential, it can be measured by using pressure chamber, it can be measured by this cryoscopic osmometer, it can be measured by using psychrometer. What is a pressure chamber? Pressure chamber is an instrument for estimating the water potential of a plant by reversing the negative hydrostatic potential, or we say tension. So, plant water tension in a plant's xylem sap. Now, using the pressure chamber, the solute potential is assumed to be 0, since few dissolved solutes are in the xylem sap. What is xylem? Xylem is it is an intimate contact with the measure of cells in the entire plant, because only 2 to 3 cells separate vascular bundles. Therefore, measuring the positive potential required to reverse the xylem sap flow will give us good approximation or good estimation of the water potential of the plant. So, pressure chamber apparatus, what it does is assume the solute potential is 0, since few dissolved solutes are in the xylem sap. The positive pressure required to reverse xylem sap flow estimate the water potential of the plant, because the xylem is intimate contact with most of the plant cells. Water column in the xylem is under tension or negative hydrostatic pressure, because during transpiration process water is withdrawn through the plant from soil to atmosphere. So, any pressure chamber apparatus, it consists of a device that is a pressure gauge, there is a pressure chamber, there is a rubber gasket for holding the plant's leaves or particular part of the plant, and that create the pressure, means and creating a pressure seal and a lid that hold the rubber gasket and seal the pressure. So, a hose connection attaches the pressure chamber to a compressed source. So, when the pressure is applied, that what is the pressure applied is measured, and then how much is the water which comes out, then it is measured. Cryoscopic osmometer is another device to measure the plant water potential. It consists of a temperature controlled thermal stage attached to a microscope. So, drop of plant sap is suspended in the depression. So, there is a depression in this particular. So, it is depression on the stage, and oil is included to prevent evaporation. So, sap water should not get evaporated. So, oil is used. The cryoscopic osmometer. It measures the water potential of plant tissue by estimating the solute potential in a plant's sap. The method is based on colligative property of solution, which states as the solute concentration of solution increases, the freezing point decreases. Means when the concentration increases, the freezing point of the material available in the sap that decreases. So, when using this method, we assume hydrostatic potential in the cell is 0 because of the cell membranes, because cell membranes get damaged due to freezing process. So, this is kept below the microscope, and these observations it monitors the what is the temperature, and then the how that does it functions. So, temperature is rapidly lowered to freeze the cell sap, and temperature is then slowly raised, and it reaches, means when the temperature is raised, then melting process starts, and then through the microscope under the last crystal in the plant cells melts, this temperature is noted and recorded. So, melting and freezing point are the same. The solute potential of the sap is then estimated using freezing point depression. As such, this is laboratory based equipment, and this is expensive, and it needs the skilled person who should operate an anti-freezing. Another limitation is that anti-freeze compounds in the plant may affect the estimation of the solute potential. Psychrometer is another device which I have told. Psychro from the Greek, it has come from, it is brought from the Greek word. It means it is to cool, and it measures water potential from change in the temperature due to evaporation or condensation. Psychrometer consists of a sealed chamber. This is the device which we are saying, that it consists of a sealed chamber with thermocouple. So, there is a device which is connected with the thermocouple, and this thermocouple attached to a temperature gauging device which measures the temperature. So, a drop of standard solution with the known water potential is placed on the thermocouple, and piece of plant tissue is kept in the bottom of the chamber. This is what we see in the device. So, if drop of the solution has higher potential, water potential than the plant tissue water, it will move from drop of solution towards leaf tissue, causing temperature to drop because of the evaporative cooling. Now, if plant tissue has higher potential than the drop solution, water will move from the leaf tissue and condense on the drop of solution, that will cause a rise in the temperature. So, it is at the point where there is no net change in the temperature that water potential of the drop of solution and plant tissue are assumed to be equal. So, this can be such type of relationship. It can be it can be graphed, or it can be plotted graphically, or it can be explained graphically, that water potential, it is plotted on x axis, and then the change in the temperature is measured on y axis, and then green line where it becomes 0 means no change, and then it gives that what is the the solute potential of the thermocouple, that is noted down. So, green line which is shows here, it is 0 temperature change. So, down to the water potential of the solution, this value is the water potential of tissue. It gives estimates of water potential of excised and intact plant tissue and solution. Equipment is sensitive to temperature fluctuations, and it is this particular thing, it is a purely fully laboratory condition. So, it needs a controlled condition to observe the soil means plant water potential. So, in this particular lecture I have tried to present here and explain you the principle and operation of various instrument to monitor soil and plant water, which are useful for irrigation purpose, which are useful for connecting with the automated irrigation system. Now, in forthcoming lecture you will be given exposure to the devices which are used for measurement of irrigation water. You can refer these books which are useful for this particular topic on soil and water, soil water as well as plant water monitoring system. Thank you very much. Good day.